Welcome to AI Podcast. I'm Alex, and with me is Maya. Today, we're digging into a new AAAI paper called SMART, which is a multi-agent framework for knowledge-intensive tasks.
Hey everyone, give me the headline first. If I only remember one thing from this chat, what is it?
SMART trains 4 small roles to work like a newsroom for an AI. One role clarifies what the question really means. One fetches documents, one highlights the exact facts, and one writes the answer that sticks to those facts. The twist is they don't just prompt these roles. They actually train them in 2 stages, so the parts are strong and the handoffs are smooth. Net result, it beats common retrieval augmented baselines and even tops ChatGPT 3.5 on several knowledge tasks.
Nice and crisp. Who's behind it?
Led by Shengbin at Fudan University, with collaborators including Siyuan Wang at USC, and it appears in AAAI 2025.
All right, set the scene. What problem are they trying to solve that others haven't nailed yet?
LLMs are great at general knowledge, but they still hallucinate, struggle with long-tail facts, and don't always use what you retrieve for them. Think of it like asking a student to open a textbook, then watching them ignore the page and guess from memory. Retrieval helps, but you get noisy passages, mixed intents, and the model often drifts away from the evidence.
So the pain points are fuzzy questions, messy search results, and then weak follow-through on the evidence. Got it. What have people tried so far?
3 main paths. First, pure internalization, which is just bigger or better tuned chat models. Second, retrieval augmented generation, where you bolt on a search module. Third, multi-agent prompting, where different prompts act as pretend specialists. Each has a gap. Bigger models still hallucinate. RAG pipelines can pass along errors. And prompt-only agents don't really learn to coordinate.
Right? Like a team that never practices together. So what's SMART's core idea?
Make the long reasoning journey explicit and trainable. They define 4 agents. Intent reconstructor, which turns a messy user question into clear search intents. Knowledge retriever, which actually pulls passages from a corpus like Wikipedia. Fact locator, which marks the specific lines that matter. And response generator, which writes the answer and cites those fact spans.
So it's like an editor, a librarian, a fact-checker, and a writer working in sequence.
Exactly, and they add special trajectory tokens that act like signposts. Those tokens tell the model which agent is speaking now and who is up next. Then they train with 2 complementary stages. Short trajectory learning strengthens each role on its own task. Long trajectory learning focuses on the whole pipeline, so the handoffs are coordinated.
I like the newsroom analogy, but where do they get training data for all these steps?
They build a trajectory dataset by combining existing public datasets and guiding a strong model to label relevance and extract fact spans. In round numbers, think roughly 500,000 examples total, with about 140,000 that mimic the full pipeline and the rest for the per-agent skills.
When you say a strong model labels the facts, do you mean they used something like GPT-4 as a judge?
That's the idea. A powerful model serves as a critic to say which passages are relevant and to point to the exact sentences that support the answer. Then those labels become supervision for the fact locator and the end-to-end trajectories.
Cool. Now, how did they evaluate this?
5 benchmarks that cover the spectrum. Pub Health for fact verification, ARC Challenge for Science multiple choice, Pop QA and Squad 1.1 for open domain question answering, and ASQA for ambiguous questions that need a longer, well-cited answer.
And the retrieval setup?
Wikipedia as the knowledge base. A dense retriever to pull candidate passages. They chunk passages to reasonable sizes and feed the top few to the system. Evaluations are zero-shot with greedy decoding, so we're not hiding gains behind elaborate prompting tricks.
Baselines matter. Who did they compare against?
A mix of general chat models and retrieval methods, all made as apples to apples as possible. So ChatGPT 3.5, Llama and Mistral chat models, and retrieval approaches like self-RAG, rate, interact, and their own modular multi-agent baseline, where the roles are trained separately but not synergized.
And the punchline on results without drowning us in numbers?
SMART consistently beats the retrieval baselines across the board, and it surpasses ChatGPT 3.5 on PopQA, Squad 1.1, and Aska. The advantages are most clear when questions are ambiguous or long-tail, and when answer quality and groundedness matter.
That suggests the fact locator is doing real work, not just window dressing.
Right. Their ablations back that up. Remove the fact locator and performance drops, especially on the long-tail and multi-hop style queries. Remove the intent reconstructor, and you also lose ground when the question format is odd or underspecified.
What about the training scheme itself? Do both stages really help?
Yes, training just the short pieces makes the agents competent, but the big jump comes when they add long trajectory training to learn the choreography. Together, they outperform either stage alone. There's also a neat data efficiency story. With a fraction of the long trajectory labels, Smart already edges out strong retrieval baselines that use more data.
Nice. Let's talk engineering for a second. What's the backbone here?
They stick to a 7 billion parameter llama model and fine-tune with LoRa. That keeps compute reasonable and makes the win more about design than sheer size.
So you could actually run this without a research lab's budget. Any details on fairness or evaluation hygiene?
They standardize a lot. Same base model where possible, same retriever and corpus, in zero-shot settings. That reduces confounds when comparing to other methods.
I like it. Now every paper has trade-offs. What are the caveats?
3 stand out. First, the supervision pipeline leans on a powerful judge model to label relevance and fact spans. That's practical, but it can import biases from the judge. Second, the retriever itself isn't trained jointly with the rest of the system, so you get good coordination, but not end-to-end retrieval learning. Third, the pipeline currently runs in a single pass. For really hard multi-hop questions, you might want loops where the fact locator and intent reconstructor talk to each other again.
So more like a team that sometimes circles back before publishing the story.
Exactly. The authors even point to that as a next step.
What about generalization? We're living in a world of domains and tools. Does SMART say anything beyond Wikipedia and QA?
The framework is general in spirit, but the experiments are on 5 well-known tasks. It would be great to see specialty corpora like biomedical or legal, or to plug in tools like calculators and databases. The scaffolding should transfer, but we need tests to confirm.
Right. If I'm a practitioner building a knowledge assistant, what is the practical advice I should take from this paper?
2 things. First, decompose the workflow into explicit roles and train those roles. Don't just prompt them. Second, teach the team to pass the baton. Long trajectory training with signpost tokens is a simple but powerful way to make the handoffs reliable. Also, make fact spans first-class citizens so answers can point to evidence.
Let's make it concrete with a story. Say I run an internal policy assistant. I ask, what were the reporting rules for a specific tax year? How would SMART handle that?
The intent reconstructor would standardize your query. Maybe split it into sub-intents like which jurisdiction and which filing type. The retriever pulls the relevant regulation pages. The fact locator highlights the exact lines that define the rule. Then the generator writes a clean answer that quotes or cites those lines. If your original question was fuzzy, you still end up with a precise, checkable response.
That's the difference between copying a paragraph and actually answering the question. Any efficiency notes before we wrap?
Because they kept the base model modest and used LoRa, training is manageable. And since short trajectory data can be mined from many public datasets, you can bootstrap without an expensive full trajectory set, then add long trajectory labels where they matter most.
All right, let's land the plane. What's our quick takeaway?
SMART shows that structure beats swagger. If you teach an LLM the steps of good research practice and train both the steps and the teamwork, you get answers that are more accurate, more grounded, and easier to trust.
And future work is pretty clear. Jointly learn the retriever, add iterative loops for tougher questions, try domain-specific corpora, and maybe distill the whole team into a single efficient model for deployment.
Exactly. Thoughtful design, disciplined training, measurable gains. That's SMART in a nutshell.
This has been AI Podcast. I'm Maya.
I'm Alex. Thanks for listening, and we'll see you next time.